Good morning, good afternoon, good evening. Thank you for joining us. We're back again from our Thanksgiving vacation, and we are continuing our sections. We have finished electron configuration. We're moving on to chemical nomenclature. So today's section is section 7.7, naming binary ionic compounds. And just like you see on your packet, that is part of our presentation. So all this information does come from your CK12 packet and website. Okay, let's get started. All right, so do you know the proper name for this insect? So you're gonna, it's going back to, your time in biology. Okay, maybe it's fresh, maybe it's not, maybe you liked it, maybe you didn't. But they're using today's introduction, they're using a little bit of biology to introduce today's topic. Who's going to help me read?
Proper naming is important for identification purposes. Medicine names just be precise or so that the correct drug is given one that will help the patient and not harm them. Biological classification of species requires accurate naming for proper categorization. The insect above has been properly categorized by genus and species, so it is uniquely identified. Names must be correct for the tracing family trees and genealogical studies. Compounds used in chemical reactions must be correctly specified in order for the reaction to occur.
Thank you, Alexia. You had some very, very large ACT words in there, and you handled them beautifully. Excellent job. Excellent reading. So back to our today's topic. So they give you 3 examples. They give you first a medical example, right? If you are sick in the hospital or at the doctor's office and the doctor has prescribed a certain medication for you, that pharmacist needs to be able to properly read the name that the doctor wrote so that he can give you so that you can receive the correct medicine, right? If the pharmacist reads something different than what the doctor wrote, it could change, and obviously it's not going to be the correct medicine, and it could harm you, right? Instead of helping you get better, you might have a negative reaction. It may make your problem worse. Okay, so always proper naming is very, very important, especially in the medical field. If you're talking about the biology field and you're trying to classify an insect or an animal and put it in the correct family so that you can trace it back to its ancestors or its predecessors, you want to know and you want to have the correct name, right? If you don't have the correct name, you're going to classify it incorrectly. And when you go to present this to a professor, to a teacher, you're going to have some points deducted. Okay. And if you're talking about the chemistry field, well, why is naming important? Well, if you don't have the correct name, you're not going to have the correct formula. And if you need a specific compound in that reaction, it's going to come out completely wrong, and it's going to make your results later incorrect. Okay, so that's how come you always have to think, hey, why do I need to know naming? Well, because in chemistry, we use naming to write formulas. We use formulas to run chemical reactions and to predict products. If you have the incorrect reactant, you're going to have the incorrect product, and whatever information we're trying to take away from that reaction is going to be completely wrong. So keep that in mind. Is proper naming important? And this is mostly for my people who are live with me here, 5th period. Is proper naming important, and why so? And you can talk about in terms of medicine, the medical field. You can talk in terms of biology, or you can talk in terms of chemistry, of course, our subject. Okay? But, tell me why proper naming is so important. You can talk in terms of medicine, biology or chemistry, because we talked about all those three examples in the last slide. Okay, I got one person typing. Excellent. Hey, Efrain. Hey, Hania. A little late, but you guys are here. It's okay. You know, we just got back from vacation. I had a tough time getting out of bed also, especially because it was so cold and my bed was so warm. Hania. All right, let's see if they're done typing. So we can know what is what. Okay. Right. If you have the incorrect name, you don't know what you're dealing with, right? That is an incorrect formula, which is going to change what you end up with on the product side of your chemical reaction. Very, very true. In medicine, so that they can give you the correct medicine, right? You get the wrong one, it's not going to help you get better. In biology, if you're trying to classify a certain animal or insect, you have the wrong name, you put in the wrong section, and then everything goes haywire after that. So today's topic, binary ionic compounds. Now here we have the meat, right? This is the most important. We are starting this section naming with binary ionic compounds. So binary, my people who are live, my students, I'm talking about 5th period, guys. If we're talking about the prefix bi, in binary, what do you think that means? Where have you seen that prefix bi? Okay, and what do you think it means? If you are riding a bicycle, what do you think that means? Binary. And as you can see, you have a periodic table. So if we're talking in terms of binary, how many elements do you think we're talking about? Binary. Like bicycle.
2.
Excellent, right? If you're talking about bicycle, you're talking about a two-wheeled vehicle or mode of transportation, right? If you're talking about binary ionic compounds, you're talking about a compound that's going to have two elements, okay? Ionic is going to telling you or is giving you another piece of information about that compound. Ionic means that it's a compound that's going to have a metal and a non-metal. Okay? And compound just means that it's connected, it's bonded in some way or another. All right, so a binary ionic compound is a compound composed of a monatomic metal cation and a monatomic non-metal anion. Okay, so they're throwing up some big words at you, right? Well, first they're saying monatomic. So that just means one metal element. Cation means that metal has given up electrons to the non-metal. Monatomic again means one non-metal element. Anion means it has gained electrons. Okay? So your metal is a cation because it's given its electrons to the non-metal. All right, now that we have that clear in our head. Ionic, metal, non-metal. Binary, two elements, compound, they're connected in a way. Bonded. All right, so you have a true and false question. A binary compound is made up of a metal cation and a non-metal anion. True or false? What do you think? Take a vote, guys. Take a vote in the chat. In the Pear Deck or in the chat. If you're not in Pear Deck, there's the link. What do you think? A binary compound is made up of a metal cation and a non-metal anion. True or false? America is saying true. All right, I got 2 people who voted. Alexia says true. 2 people on Pear Deck have said it's true. So we got already about 4 votes that have said true. Anybody else think it's something different? Does anybody else think that it is a false statement? Mario is thinking it's a false statement. Okay. Let's see. Anybody else? Oh, what? Oh, there. We got some flip-flopping. All right, guys. That is a true statement. A binary compound is a metal cation with a non-metal anion. True. All right, so now we're going to talk about actually naming these compounds. When examining the formula of a compound, in order to name it, you must first decide what kind of compound it is. For binary ionic compounds, a metal will always be the first element in the formula, while a non-metal will always be the second. The metal cation is named first, followed by the non-metal anion. Subscripts in the formula do not affect the name. Okay. And it breaks it up into steps. Sorry, guys. It breaks it up into steps. Step 1. And they're talking about your metal. Write the name of the cation, which of course has a positive charge. So in this case, the metal. If you need a periodic table because you don't have one, you can click here on important information. Excuse me. All right, so here you have a periodic table in case we need it, because we will need it. Number 2, write the name of the anion, the nonmetal, but shorten the name of the nonmetal and add suffix IDE at the end. So prefixes always come out in front, suffixes always come out at the end. All right, so whatever nonmetal you have, I always say take off the last 3 letters of your name and add IDE. And then they provide an example. Sorry. ALF3. ALF3. So first off, what metal is Al? So you go to your periodic table, Al, element 13, aluminum. So you write the way you see it. Don't change the name of the metal. In the case of F, your non-metal, it's element 9 over here, originally known as fluorine. What would fluorine change if you take off the last 3 letters and add IDE? Can somebody type it out in the chat? If fluorine, if the ending changes to IDE, I need somebody to type it up in the chat. Okay? So if you're talking about the example, AL, very good, Oscar. ALF3, it's now going to be called aluminum, right? We're not changing the first metal name. Although the non-metal, your second element, fluorine, changes just like Oscar said or typed in the chat, fluoride. ALF3, its proper name is aluminum fluoride. Excellent. Any questions in the example? All right, we have 4 questions that we're going to do as practice on Pear Deck. Oscar, you're doing number 1. Yeah, Alexia, you're doing number 2. Type it up. Try it. If you get it wrong, I'm going to help you fix it, okay? But I want you to try it first. Irvin or America, try number 3. Irvin, try number 4. And everybody else, try any of them. 1 through 4. Okay? Oscar, 1. Number 2, Alexia. Number 3, America. And number 4, I think I said Irvin. Try it out on Pear Deck. If you're not in Pear Deck, just use the Google Meet chat. Yes, name it. Name it. If you need a periodic table, use your packet number 1, your first 6 weeks packet or your second 6 weeks packet. I believe there is a periodic table in there. All right. Oscar, he's not using Google Meet. The Pear Deck, he's using Google Meet chat. Let's help him out. Let's discuss. All right. So number 1, NaCl. He says Na is named sodium. Excellent. The second one is originally named chlorine, right? Cl is a nonmetal. It's originally chlorine. Oscar says that it is now, using the proper rules, sodium chloride. And he's correct. Number 2, Alexia, help me out. KBr. What's the name of the element K? All right, and if we go to the periodic table here, K. Element 19, Alexia, type it up. Right here. Br, element 35. Type it up. I'll help you with the rest. What's the name of K? What's the name of Br? Element 19, element 35. Yeah, Alexia, are you there? Oh, she's probably helping. Okay, somebody help her because she might be helping with her brother and sister. Guys, K, what's the name of K according to the periodic table right here? What's the name of K? K, help me out, guys. Oscar, Irvin. K, what's the name of K? What's the name of BR? Irvin, Oscar, help me out, please. K, element 19. BR, element 35. Help me out, please. Is anybody there? Oscar, Efrain, Irvin, America, what's the name of K? Right here, element 19. Element 19, potassium. Okay, what about Br? Element 35. Change the ending to IDE. What would it be called? Bromine, okay? Take off the last 3 letters, Ephraim, and add IDE, just like Oscar did, and you're going to get potassium bromide. Very good. Very, very good, boys. Number 3, Mg and F. Number 3, MgF2. What would it be called? Mg, and I'm going to use the periodic table. Very good. Mg, element 12, magnesium. Okay. F, element 9 again. Do we use this one? Oh, no. Fluoride. Excellent. Excellent. Okay. What about CaO? I think Irvin had already said Ca is calcium and O is oxygen. But what would oxygen change to, Irvin, if you added IDE and removed the ending of oxygen? What would it be called? What's the proper name for CaO? Calcium is correct, but oxygen becomes what? What does oxygen become now? If we take off the ending and add IDE, oxide. Very good, Oscar. The proper name for CaO is calcium oxide. Good job, Oscar. Good job, Irvin. Good job, Efrain, and anybody else who helped. Very good, guys. Here you have some more examples. KF, potassium fluoride. Na3N is sodium nitride. Ca3P2 is calcium phosphide. Excellent. All right, now they're going to go into some of the information for tomorrow, okay? And I'm just going to read it. I'm not going to talk about it because I don't want to confuse you, okay? So I'm just going to read it real quick. Notice that in each of the formulas, the overall charge of the compound is 0, okay? Don't worry, we're going to talk about it tomorrow. Potassium ion is K plus 1, while fluoride ion is F negative 1. Since the magnitude of the charges is equal, the formula contains one of each ion. This would also be the case for a compound such as MgS, in which the ions are Mg plus 2, S negative 2. For sodium nitride, the sodium ion is Na plus 1, while the nitride ion is N negative 3. In order to make a neutral compound, 3 of the plus 1 sodium ions are required to balance out the single negative 3 nitride ions, so Na is given a subscript of 3. For calcium phosphide, the calcium ion is Ca plus 2, while phosphide ion is P negative 3. The least common multiple of 2 and 3 is 6. To make the compound neutral, I need 3 calcium ions, which have a total charge of plus 6, while 2 phosphide ions have a total charge of negative 6. The Ca is given a subscript of 3, while the P is given a subscript of 2. And we're going to talk about all of that in detail as to why tomorrow. We're going to watch half of this video because he goes into stuff that we're going to be talking about later in the week. So I'll only watch a little bit. I'm going to mute it because it goes into commercials and then it shows the video. Andale. I don't care. Go. Okay, now we got our stuff. This is our portion.
Welcome to Naming Ionic Compounds. In the previous video, we talked about how to name ions, and since an ionic compound is made up of ions, it's only going to be a short step further to name ionic compounds. First of all, ionic compounds are made up of a metal ion and a nonmetal ion. The metal ion has transferred an electron or given an electron to the nonmetal ion, and so the metal becomes a cation, and the nonmetal becomes an anion. For naming ionic compounds, we always name the metal first and then the nonmetal. So cation always first, then anion. Sort of like a first name and a last name. So the metal is going to be the first name, the metal cation is going to be the first name, and the nonmetal anion will be the last name for all of our ionic compound naming. Let's look at a simple example. The metal is calcium, and the nonmetal is chlorine. If we name these individual ions, We know that the metal ion should be just named calcium because it's just the name. And we know that chlorine, when it's an ion, becomes chloride. So just like we said, first name, last name, the metal is the first name, the non-metal is the last name. So this becomes calcium chloride. Let's take a look at a second case that's a little bit more complicated. For our second case, let's look at a compound made of iron and oxygen. This is going to be a little bit more tricky than the last one.
All right, so right now he's going to go into another step for naming some binary compounds. I don't have the reference material that you need to properly name some of these metals, because some metals have just one oxidation state or one charge, and then some metals have more than one charge, and you need to decide which metal you're talking about. Because, like, for example, you have iron 1, copper 1 and copper 3. So which one am I using for this formula, miss? I'm going to show you how to do this tomorrow when I get that reference material. For today, just remember the metal doesn't change. The non-metal does. It changes to IDE. And then we'll talk about these Roman numbers tomorrow. I need to talk to one of my coworkers.
Because iron is one of those transition metals that can have multiple oxidation states. Iron can be a 2+ ion, or iron can have a 3+ ion. So we can't say iron oxide because that's too vague. Iron oxide doesn't tell us which kind of iron is present in this compound. So how are we going to figure out if it's 2+ or 3+? We have to think about this a little bit. And the way we can think about it is by examining the oxygen. We know that because oxygen has 6 valence electrons, oxygen is going to form a 2- ion or -2 ion. We also know that a compound overall has to be neutral. So if the oxygen in this compound is a -2, then the iron must be a +2 to balance it out. So we know we must have this type of iron. And we know how to name the ion. This is an iron 2 ion. So now we can use our first name, last name method, with the first name being the metal. So iron 2, and last name being the non-metal ion, oxide. And this is the name of FeO.
All right, and we're going to stop there because he goes into something that we're not going to cover until later in the week. So let's pause it and stop it. Let's finish up our lecture on Pear Deck. Your summary and your review questions. A binary ionic compound is a compound composed of a monatomic metal cation and a monatomic non-metal anion. The metal part of the compound is named as the element. The non-metallic part of the compound is named by dropping the end of the element and adding IDE. For binary compounds, it is not necessary to indicate the number of ions in the compound. Your review questions. Number 1, what is a binary compound? Number 2, which of the following is not a binary compound? And then number 3 asks you to name the following compounds. All right, so let's get it done. Let's see how much we can do. I'm going to end Pear Deck. Thank you for those of you who were listening and participate. Oh, I didn't indicate which one it was. Oh, well, I'm going to stop recording. Remember, guys, if you join me in class, I always help you with the review questions. But if you are not here with me, I